Now let us continue with the last three techniques. So binder jetting. So binder jetting technique that is used for the metal polymers and ceramics. In binder jetting, what is happening here? So this is the additive manufacturing technique that create the parts by selectively depositing a liquid binding agent. So here we are using the liquid binder, and this liquid binder it is sprayed on the metal powder, and it forms it binds that the molecules of the metals. Okay, so it binds the metal molecules, but without melting. Okay, so that is very important, without melting. Okay, and afterwards that part is taken for the heat treatment, okay, to provide the strength to that particular part. So initially this part is not having the strength, it just get bind. Okay, so only the molecules are bind together using this liquid binder. Okay. So this is low cost printing as compared to the other 3D printing process. It is used for metals, polymers, and the ceramics. Now, a thin layer of powder material is spread across the build platform. So here there is a layer of the metal powder. After that, we have the binder, liquid binder. Droplets of the liquid binders are spread over this the layer of the metal powder. The binder act as an adhesive, bonding the powder particle together to form a solid layer of the part. Once the layer is formed, the piston moves down, and the roller it forms the another layer of the powder. Then again the liquid it spread the liquid binder, it is spread over the layer, it forms the second layer, and the process get repeated. Okay, so now once the part is formed, so I have already told you the it is taken, it undergoes a curing. We have to take that part for the heat treatment process, where the heat is applied to harden the binder and strengthen the part. Okay, the powder get removed, the unbound powder gets removed, leaving the unwanted part. And for post processing, we can take a number the post processing process that we have discussed earlier. Applications: rapid production of prototype for testing and validation, tooling, creation of molds, cores for casting processes, end-use part, manufacturing of complex functional parts for the various industries, including aerospace, automotive, and the medical. Okay. Now, after binding, we have the material jetting. Now, what is there? What is the difference between the binder jetting and the material jetting? So, in this case, this is also additive manufacturing process where droplets of liquid photopolymer or other material. So here we have the two containers where we have the support material and the build material that comes here, and then these are comes on the in the forms of the droplets on the platform, and these droplets are cured using the UV light. Okay, so in material jetting, the droplets of build and support materials are selectively jetted onto the build platform, either by ultraviolet light or heat to form a 3D object. Okay, so in case of this the material binding. Okay, in case of this in case of this binder jetting, so we have used here the liquid binder. Okay, and the powder is here. But in case of this material binding, the material is here and the UV light is also here. And when this the material comes in the form of the droplets, and when it comes on the form of the droplets on the build platform, so it is cured using the ultraviolet light. Okay, so again the process is same. Here it is given, this is the material container. It comes in it comes in the form of droplets on the bed. Then we have the UV curing light which solidify the droplets, okay, required droplets, and form the layer. Okay, after that the second layer of the second layer second layer of droplets, it falls over the bed, and then the process continues. So it is the first, then second and third. So something like this, it goes one by one. Layer by layer building support structure. Okay, if there is support structure, we can remove that one using the post processing techniques. During printing, support material is jetted alongside the build material to support overhanging features and complex geometry. So both the materials are there. If support is there, so support material is used, and for building the main material, the build material it is used. Okay. So applications are prototyping, medical models, dental application, consumer products, and jewelry. Okay, so just read it out. After that, the last process is continuous liquid interface production, that is CLIP, continuous liquid interface production. Now we have discussed about the SLA technique where the same process we have taken, that is the wet polymerization process. Now here it's a different technology which is developed by Carbon company. So this is developed by the Carbon company that uses photochemical process. Now what is happening here? In case of this SLA, it works on the wet polymerization process. This clip is also works on the wet polymerization. Now, what is the difference between SLA and this clip? So, SLA builds part layer by layer, okay, using a UV laser or projector, okay. While in case of clip, it uses a continuous process where UV light cures resin through an oxygen permeable window. Okay, so now this is a continuous process. That means in case of SLA, after one layer, the bed it moves up, while in case of this and then again it moves down for the second layer. But in case of this clip, the bed when it moves up, it completes the total part. Okay, so in one move only, the total the part get formed. Okay, so how it so how this the part is formed in the clip. So it is having the resin pool. So we already seen that it is having the resin pool. Below that resin pool, so process begins with the pool of liquid polymer resin contained within a transparent window at the bottom of the build area. So we have this build platform, we have this resin, and then we have here the dead zone. Uh, this window is permeable to oxygen and is often referred to as the dead zone. So here the oxygen is here the zone is there where this is oxygen permeable window where the oxygen molecules are there. Okay, or the air can flow here. Okay, so this is the printed part. So this is the printed part. This is the dead zone. This is the dead zone, and now the resin is coming from this side in the oxygen in the dead zone. Okay, dead zone means the permeable the window where the which is permeable to oxygen, that is called the dead zone. Now resin comes in this dead zone because of the light, the layer is formed and then it moves up. Then again for the second layer, the resin is there. The resin comes here, the UV light, it forms the layer, and again that layer it moves up. Okay, so the continuous layer formation occurs in the dead zone and then the layer moves up. So that's why here in case of this clip there is a continuous formation, there's a complete formation of the product in one move. Okay, so if you refer this digital light projection, so ultraviolet light projector shines UV light through the transparent window, curing the resin layer by layer. The light selectively hardens specific areas of the resin to form the desired shape. The oxygen permeable window creates a thin layer of uncured resin, dead zone, between the window and the part being built. So oxygen creates a thin layer of uncured resin between the window and the part that been built. This prevents the resin from adhering to the window, allowing for continuous production rather than a layer by layer approach. Okay, so complete the layer is formed here in the dead zone. Okay, continuous as the UV light cures the resin, the build platform moves upward continuously. This continuous motion coupled with the dead zone allows the new resin to flow into the space between the part and window, enabling a seamless and rapid build process. So as the UV light cures the resin, the build platform moves upward continuously. This continuous motion coupled with the dead zone allows the new resin to flow into the space between the part and the window. Okay, so that's the resin is continuously coming here. It forms the layer and it is moving up. Once the pass is printed, it is removed from the build platform and typically undergoes a secondary curing process using the UV light to heat to enhance the material properties to ensure complete curing. So I have shown here. Now you see this is SLA printing, and now here you see this is the continuous liquid interface. Now it is a little bit fast, but this is a very slow process. Okay, but the bed it moves only upward only once. Okay, then the applications are prototyping and use parts, medical devices, variables. So all these are the applications for this. the clip method. Okay, so continuous liquid interface production. So thank you very much. This is the end of your unit number 3.